Welcome back to UAP Rant. This is episode 17 in the series. For those following the podcast, the last few we've been talking about the importance of the relationship between James Clerk Maxwell and Albert Einstein in terms of space-time, because a lot of Einstein's theories about space and time are based on Maxwell's original quaternion notation, linking four space geometric potentials to three space vector fields with these equations. Of course, the modified equations we have now are not Maxwell's original work, because they are three-dimensional scalar vector fields. So we're going to build out more on this, because we've been talking about how this relates to UAP or UFOs, our orb and rod research and interdimensional anomalies, and we'll be circling back to that on and off in subsequent podcasts. So a little bit more detail today, taking some notes on this, of course, because the scalar part of the quaternion notation mathematically is linked to three imaginary components that represent physical space, so that we get an operational framework in four dimensions that can describe rotation, space-time, and the interplay between three space dimensions and the fourth dimension, which is time. And of course, Einstein ended up calling the fourth dimension time. Now, in Maxwell's quaternion notation, the fourth dimension is a scalar quantity, of course. And he used it to describe the relationship between electric and magnetic fields based on his electromagnetic atom. So those equations linked spatial changes in the fields with time-dependent variations, and that set the stage for Einstein's understanding of space-time in his work subsequently, because Maxwell died well before his time, of course, and Einstein adopted a lot of what Maxwell was trying to show. Now, linking to the fourth dimension, that's the scalar part, of course, of the quaternion notation, with space occupying those three imaginary components. So we get a quaternion that is interconnected with space. And just taking on a few more notes here before we talk more about UAP, was what Heaviside did to it, of course, in terms of the fourth dimension. Now, he used vector calculus notation to simplify the original quaternion framework. So he presented the equations as the four familiar differential equations to describe electric and magnetic fields, of course, with Gauss's law for electricity and magnetism, Faraday's law of induction. Then we got Ampe's law, of course. So they described how fields evolved in space and time, tying the spatial variation to time-dependent changes in three-dimensional space. So by simplifying those equations, they were more easily interpreted within the framework of Einstein's special relativity. So they included the time-dependent term in Maxwell's equations to demonstrate interdependence of space and time, a key feature of the fourth dimension, and also the consistency of the speed of light, which brought in as well for that purpose. Now, in terms of relativity and a unified framework, those quaternions were the precursor to Einstein's space-time, of course, and hinted at the unity of space and time. That was even before Einstein formalized this whole concept, because the quaternion scalar part corresponded to Einstein's time, which is the fourth dimension. And that's why I've been saying that we need to view time as scalar, not only four-dimensional, but scalar, which is what Maxwell's original work was. And I was, in a previous podcast, relating that to the fact that the past, the present, and the future all exist simultaneously in scalar time in the fourth dimension. So bringing that around to Lorenz transformations, so when Heaviside's vector reformulation of Maxwell's equations aligned with the Lorenz transformations that described how space and time coordinates change between observers moving at different velocities. So we get the Einstein's theory of special relativity about, for example, here imagine someone travelling around on an arrow at the speed of light and an observer watching that, and we came up with the theory of special relativity. So in special relativity, the electric and magnetic fields transform into one another under the Lorenz transformation and further unifies space, time, and electromagnetism. All right. So that's how does that apply to UAP and UFOs? Just briefly, we're looking at the fact that when we look at the 5 observables, which we'll talk about in the next podcast, is that those 5 observables seem to relate back to the fact that we need to consider the 4th dimension time as scalar to try and further understand those 5 observables and why they don't match what we currently know in terms of aeroframes and Newtonian physics. So to do that, we need to consider a scalar quantity being involved in there and look at how these UAPs can appear, disappear, reappear, have instantaneous acceleration, etc. So I'm going to leave it at that for now. In the next episode, we'll talk about how the 5 observables relate to the Maxwell-Einstein work and time as scalar in the 4th dimension. Thanks for listening.